Hello. So I do HPC for the last 15 years. Actually, on Oktoberfest, it was exact anniversary when I start working. But I think, maybe a mistake, but I'm pretty sure that I am the most young Zabbix user in the auditorium. So we use Zabbix for monitoring less than a year. So who are we? Chemistry faculty in the Weizmann Institute. So very traditional HPC usage, number crunching, a lot of classical calculations, differential equations, all the stuff. But we have very long history of using HPC. We even used real supercomputers like SGI cluster, SGI Altix. Today, this is our system. We have almost 600 compute nodes, hosts in your terminology, with some quite a big memory. Total almost about 25,000 cores. We use InfiniBand for interconnect, for data exchange, and for storage. We use Ethernet for management, provisioning, monitoring, and everything else. We use parallel file systems. Currently run Sentence. PBS Professional, it's a system for submitting jobs. Like on a supercomputer, nobody works like in Windows. You prepare a file, really in console. You say qsub. It goes to a queue, wait some time, and then it runs, and you get results back. It's very unusual this day. We use VMware, as we told, to rule them all on the earth. And we have 3, and it's not factorial. We're proud that we are only 3 people to manage this system. But it turns out that 3 users on Zabbix, it also makes our life easier. And we use hardware, not VMs, not cloud. Like this is our system. It's a 12 48U racks full of hardware. We use HP, Dell. We have login nodes. Login nodes is where users come in and make troubles. Switches of all sorts. We work at 100 gigabit per second with InfiniBand. We have several storages. We have storage all flash for VMware, and we have central storage with parallel file system, which runs on DDN. And we started having problem with monitoring. So it's a time to upgrade to Red Hat 8 or some on clone of Red Hat 8. And there is a problem with operating system level monitoring. We used Nagios and Ganglia before. And you cannot use Nagios alone in HPC because it is not scaling. And Ganglia works with client similarly to Zabbix. So with Nagios, you only check SSH and ping, and Ganglia, you gather all other metrics, which works very bad relative to Zabbix, but it worked somehow. But it is Python 2. So in Red Hat 8, it doesn't work anymore. We have some hardware monitoring. Each vendor has its own system for monitoring hardware, but Aruba switches, which were previously HP switches, they do not provide normal monitoring tool. So I cheat you a little bit. For a couple of years, I used Zabbix to monitor Aruba switches via SNMP. So I'm not completely new, but on a big system, very new. And as I told, we have problems. Nagios dead, at least open source Nagios. There are no new line of code since 2018. Ganglia also dead. 2 reasons, Python 2 and no new code. We couldn't monitor HP switches with some normal tool provided by a vendor. We had a lot of useless alert, and it was a great lecture yesterday about alert fatigue. So it was a crucial point to have a good alerts. We have flooding alerts. It was a complicated setup, like make a friendship between Ganglia and Nagios via RRD database cached via sockets. You don't want to know how to do it. It was faulting every time, so I kept monit that was restarting ganglia. Once in a couple of weeks, I had to clear cache and manually restart it. So very, very nice and friendly system. So I built a list of requirements in my head, and you can understand that during 15 years, I have a little bit of them. The first requirement, which is unique for HPC, is scalability. You can tell me that in many environments, scalability is important, but in HPC is very important. Because suppose you have a check, you test something, and your check lasts only 2 seconds, but I have 600 nodes. So if I do 2 seconds on 600 nodes, it's already 20 minutes. And my system is not very big. In Barcelona, they have 4,000 nodes. In Krakow, near, they have a couple thousand nodes. So 2 seconds multiplied by 1,000, it's a long time. Of course, we need auto-discovery, because when I purchase like 100 nodes and I want to add them to Zabbix, I don't want to do it one by one, or to any monitoring system. We want to have different host groups, because we have hosts with GPU, hosts without GPU, management hosts, compute nodes. We want to have some custom checks to get only useful alerts. And useful alerts means that when I get an email with a problem, this email suggests that I have something to do with it. I don't want to get email if I have nothing to do with it. It's informational noise. And of course, we want smooth operation, not like with ganglia. And monitoring, alerts, sysadmins. But at the end, you want to develop your unit or your business. And to develop your unit or your business, you need some strange, it was previously papers, colored papers, but now it's mostly digits in the bank. They call it money. To get money, you have to go to management and to do some presentation. To do a presentation to a management, you have to get a nice picture. So surprisingly, monitoring systems sometimes also provide you a good picture of utilization of your resources. So we start thinking. It's very untrivial. The frontal part of brain is totally exhausted. So what are our alternatives? Strange enough, I never met Zabbix on supercomputing conferences, which I visit at least every year, sometimes a couple of times in the year. But it works in the community, so people told me about it. Somebody uses Prometheus for hardware, but it's very complicated to configure on the hardware, not in Kubernetes. And I actually didn't find any good commercial alternatives. So Zabbix, let it be. But how to start? And I found the secret link. I will hide it out, because nobody should know about it. But this channel is very good. I think Dmitry is in auditorium. Sitting on this channel a couple of hours actually gave me an idea what we need. And we had the luxury of starting from scratch. So I pick up the correct database according to instructions and made some idea of sizing. And we started our journey. So this is our journey. Small VM, 16 CPUs, 32 GB RAM, disk for data, 3 interfaces, 1 for data, 1 for out-of-band, and 1 for external access. We run it on Rocky 87. And according to Dmitry instructions, we started with new Postgres and timescale DB. So we never had problems with housekeeping. And actually, the only changes we made to default configurations that we shortened the history for 14 days and trends for 60 days. But you see, I strike it through, because we had an incident a couple of weeks ago, and we find out that we need more data in our Zabbix, so we changed history to half a year and trends for 1 year. So you can see this is typical hour of work of our Zabbix server. It's pretty stable in terms of disk, CPU, memory consumption. Like, it's a little bit misleading because the memory changes only by 1%, but in the graph you see it like big changes, but actually it's pretty stable. This is 1 month view from the vCenter side. So CPU is stable, memory very stable, disk 3 megabytes per second for all flash under VMware. It's like very acceptable load. And this is metrics from our system. So we have more than 800 values per second. So our system, turns out, it's not very big. So we got stability, we got automation. What else? This is our main dashboard. And you see here alerts, and underneath, it turns out that Zabbix has many useful properties. For example, you can run a script, and if we place a compute node offline, so we take it out of PBS with some type of comment, Zabbix can look at it and set maintenance on it, so we don't get alerts on a machine that from the beginning we know that we're doing something with it. It could be broken, it could be tested for a new software, it could be tested for new drivers, doesn't matter. The only important thing is this dash equal in the comment. Not everything we check by Zabbix agent, but we check it from Zabbix. For example, there is no reason to check PBS service on every compute node. I can just ask PBS server, tell me who is not good, who is offline, who is down. So with one command from Zabbix external scripts, I get all the information. The same with GPFS. I don't need to ask every compute node, is your file system up and running? I can ask the cluster manager, the main GPFS server, who is not good, who is a bad guy, tell me. Or if we have some connectivity issues, or if we have IO wait, all this stuff. We check license servers, because some of the software uses license. Even in academia, we use some commercial software, strange enough. And we use more than standard service and TCP tests to check that the licenses are okay. And we check some specific services on different infrastructure hosts, like on DNS, we check DNS, on LDAP, we check LDAP. And it's turned out that Zabbix even knows how to manage, like people do it to extreme, managing their home, but we, for example, with on some type of hardware, for some reason, the Ethernet card goes down from 1 gig to 100 megabit. So we have a script that we can run, clicking on a problem, please fix, and Zabbix not only alerts us, it also fixes it. So it's a good guy in the team. What about the alerts? What type of alerts we want to get? Here is a typical day, so we have some DHCP servers. It doesn't work on our provisioning server. We have some high swap usage on compute node. By the way, high swap usage on a compute node, it is shown here, but I will not get mail on it, because I don't care. Job will survive or not. But typically, compute node has 100% CPU utilization, may have close to 100% memory utilization, may swap And I don't care, I am happy. If job used all the resources and survive, and the scientist gets the result, this is the purpose of our existence. We want to squeeze every ops of our hardware. This is the HPC world. So I will not get mail on it. From the other hand, temp partition or login node, I have to take care. I have to see who is filling up the TMP and clean it. And probably write mail to user, please avoid keeping your files in common TMP. So in order to differentiate the alerts we get, we use host groups, like we organize our host in different groups. Compute nodes are divided to two categories, CPU compute node and GPU compute node. This is also convenient for taking metrics for reporting, to have a nice chart for the management. Ethernet switches, of course, different group. They are monitored via SNMP. Infrastructure nodes, which are login nodes, PBS machine, GPFS server or NSD servers, name servers, license servers, provisioning machines, hardware monitoring servers. Every one of them has different metrics that are interesting. So this is a part of screenshot of our host groups. Oh, sorry, it's from a different representation. So probably better call admin and not a lawyer. So we send email only on high disaster, because again, we don't want to get alert fatigue. This is very important. When alerts are flooding, you stop reacting on them and you may miss some really important stuff. And there is deep difference between the compute node and infrastructure node. Compute, basically, I care if it's alive or not. Like if compute node is down, then yes, I have to probably restart. Like it could be down from two reasons. Either job was too heavy and it hang out, so I have to restart it, or there is a hardware problem, so I have to put it on maintenance and to call the support or to fix it another way. I might be interested if there is some TMP or var partition full on the compute node, but that's all. From the other point, on infrastructure nodes, I want to monitor services, I want to monitor their memory, because mostly on Linux servers that do something useful, memory leak is an issue. So they had to do quite a big work on Zabbix standard template for Linux servers. For example, you can pay attention that CPU utilization is disabled for the compute nodes. And memory utilization is disabled. Because I don't care. I want CPU to be 100%. I'm not interested in getting alert, you utilize your machine too high, 90%. It's okay. And we have this nice trick of putting command in PBS and offlining a machine, and then Zabbix automatically takes it to maintenance, and we do not get alert. But one picture cost $1,000, or maybe $1,000, or maybe $1 million. And unfortunately, this is only pictures that we couldn't get in Zabbix, but it turns out that we have to upgrade to 7, and then this picture we also will get from Zabbix. Here we have example of utilization of our cluster, CPU heat map, memory heat map, GPU heat map. So I can immediately, by looking at this picture, not only to go to management and to ask some money or funds, or I can see that I have too much memory in my system. So we overestimate our requirements for memory and too few GPUs. Because GPU are utilized much higher than CPU. So this picture immediately, and all this data came from Zabbix. We get this data, and we immediately understand from one glance that we need less memory and more GPUs. So, conclusions and some thanks. We use some metrics outside of Zabbix, like GPS GUI, and last incident showed us that it's not good to rely on GPFS when we have GPFS problem. This is the reason why we increased the history and trends on Zabbix, because Zabbix was reliable and GPFS GUI not. We use some BGFS performance from BGFS. Actually have no idea if it's possible to gather metrics in Zabbix. We gather in InfiniBand metrics in UFM. Again, I have no idea, maybe it's possible to gather in Zabbix. And it might be advantage to gather everything in one place because you don't need to remember on upgrades that you have these checks here and these checks here and these checks here, and you check this metrics here and this metrics here. So probably we may optimize this a little bit. We did minor upgrade and it was very smooth. As far as I understand, we will go for a major upgrade when version 7 will go out. We use Rocky, probably will need to switch to RHEL because IBM behaves like IBM and declared war on open source at the end of June. And we currently use only 2 dashboards. Actually, I am cheating. We already use 3 because we started creating the third one during the summit by looking at the lecture, so it was a very useful experience. We do not use reports. I looked at it, didn't find it that we need it. And I want to thank a member of our team who made all this possible, Andrei Vasiliev. Questions?
Yes, thank you. There will be.